The search for new lands is inscribed in human genes. The Earth is not enough. Time for a new cosmic cape, the Moon. We choose to go there, not because it's easy, but because it's hard. This will be the first manned base on the Moon in the history of mankind.
Planet Earth is protected by the atmosphere, the layer of air and gas that surrounds it. The atmosphere shields the Earth from solar radiation, keeps the temperature balanced, and protects us from meteoroids. On the Moon's south pole, you can see almost perpetual sunlight on the horizon. This is the site of our lunar base. Conditions on the Moon are very different from those on Earth. Because the Moon has no atmosphere, there is no protection from solar radiation. There are extreme temperature fluctuations. And there is no protection from gamma radiation, and no protection from meteoroids. The lunar lander has detached from the rocket launch and is on a course to Shackleton's crater, the Moon's south pole. Inside the lander is a cylinder which contains an inflatable dome and 2 robot 3D printers. After the cylinder containing the habitation capsule has been unloaded, a dome is inflated from one end. This provides the support structure for construction, a little like scaffolding is used to build on Earth. The lunar habitation is built by a robot-operated 3D printer. At one end, it has a scoop to collect the regolith. In the centre are the containers for the printing material. At the other end, there is a robotic arm with a printing head. The robot collects regolith from the Moon's surface. Layers of this moon dust are built up over the dome to create the protective shell. This process takes about 3 Earth months. The shell is made up of a hollow, closed cellular structure. Under a microscope, it would look very similar to the close-up of a bird's bone. Like a bone, it is light and incredibly strong at the same time. When the lunar base is complete, it can house 4 people. Inside the dome, they are protected from meteorites, gamma radiation, and high temperature fluctuations. The original capsule functions as an airlock and technical support module. The skylights draw daylight into the living and workspaces, which are sheltered within a pressurized enclosure. This method is a pioneering advance in space-age construction. At Foster & Partners, we're used to designing for some of the world's most extreme climates. We often use materials found locally to create sustainable buildings on Earth. While the Moon is an exciting new territory for architecture, the value of this logic endures.
The quest to explore unknown boundaries is a human trait that leads us to new and exciting frontiers. There is international support for establishing a moon base in the near future as the next logical step in exploring the mysteries of our solar system. But how do we bring humans to the moon and keep them there? One obstacle is the extraordinary cost. Each rocket launch requires an enormous effort and a great deal of resources, such as capital, intellectual know-how, time, labor, and material. To find ways to decrease these upmass costs, ESA's Project Urban studies the feasibility of producing much of the infrastructure, machinery, long-duration goods, and on-demand items that are critical to a lunar base directly on the moon. The focus is on additive manufacturing, or 3D printing, and the smart use and reuse of materials that have arrived from Earth or that have been extracted directly from the moon. The study devises a 3-phase plan for establishing a lunar base. Phase 1, survivable, addresses the most fundamental elements needed to protect a small crew. In Phase 2, sustainable, the lunar base is expanded to accommodate a greater number of research, fabrication, and habitation facilities. In Phase 3, operational, a fully functional base is realized for long-term habitation and work on the moon. The Urban study conducts a survey of all available printing materials, including all material resources originating in the lunar environment, the material composition of all component parts launched from Earth but no longer useful on the moon, all waste material generated during lunar base operations, both organic and inert. The many additive manufacturing processes that currently exist or are in development bring the printing of any item closer to reality. The Urban Project establishes a searchable database to help identify the most resource-efficient way to produce the required items using the best material and printing processes available. Someday in the future, humankind will exist in contexts beyond our wildest imagination. Urban is one of many steps towards sustainable life on the lunar surface and beyond.
The closest celestial body from the Earth, Earth's only satellite, the Moon. The Moon now becomes a station for humans to travel into what was considered outside human limitation, space. The beginning of a new future, lunar construction. A lunar orbiter launched from Earth enters the lunar orbit. It initiates remote reconnaissance as it explores the lunar surface to identify sites for construction. It collects and analyzes geographical, resource, and environmental information, identifying the most optimal location for construction. A robot for more detailed reconnaissance arrives at the construction site. The first task of the robot is to go over the ground and with its camera collect detailed geographical information. And with its exploration drill collect geological information. It also confirms the location of a safe lava cave for human habitation. Another robot conducts construction material testing with the Moon's resources. The robot's thorough and comprehensive reconnaissance is an imperative step of evaluating and verifying technology before actual lunar construction. Based on this verified technology, robots with construction equipment make their landing. The first step is to set up a power station for energy supply. And next is the construction of a landing pad to prevent the occurrence of dust, which could be deadly for astronauts. And the construction of a blast wall for protection from meteorites. This is the lava cave, confirmed in Phase 2. It is the optimal place to keep safe from the strong radiation and meteorites flying around space. And it is where a habitation zone will be built for humans. Finally, the lunar station construction phase. Astronauts arrive and safely enter the lava cave where humans will habitate. Roads, an advanced base, and power station for both habitation and development will be constructed. Overcoming severe environmental conditions, this will be the completion of the city of the future humans have dreamt of. Based on the rich energy resource of the moon, we are preparing to travel further into space. The endless challenge for a bigger world. The research for the future continues on.
It's time to return. This time, to stay and take our next steps to becoming a spacefaring civilization. One of the competitors from NASA's 3D Printed Habitat Challenge has received NASA funding to start development of an off-world construction system that could support a sustainable, long-term presence on the moon. Icon.
Icon is a construction technology company based in Austin, Texas. We built the first permitted 3D printed home in the United States and are printing communities of homes throughout the world. The team is driven to innovate on behalf of all of humanity. From the very founding of Icon, we have been thinking about off-world construction. It's a natural progression, using automated construction technologies to advance humanity's home to other worlds. The moon is an incredibly challenging place. 500-degree temperature variations, craters that are thousands of feet deep, extreme radiation, electrically charged super abrasive dust, all within the hard vacuum of space. We're developing entirely new technologies to operate in this environment, to build a home for humanity 250,000 miles away. Icon is partnering with two incredible architecture firms in order to determine what humanity will actually need to live on another world.
To explain the power of architecture, you can explain the Danish word for design is form-giving, which literally means to give form to that which has not yet been given form. In other words, to give form to the future. And of course, this becomes blatantly obvious when you travel beyond Earth and have to start building and imagining how we're going to live on an entirely new planet. In a way, you can say that the answers to our challenges on Earth may actually be found on the moon.
Our mission at Search Plus is to conceive, investigate, and develop innovative human-centered designs, enabling human beings not only to live, but to thrive in space environments beyond Earth. We feel so fortunate to be working with Icon's team of driven and like-minded individuals on this tremendous and groundbreaking project.
New technology is created. This technology empowers the architecture. The architecture then reinforms the technology, and entire new horizons are opened. This is going to be the most ambitious architecture and construction project in recorded human history, and an incredible adventure. We are going back to the moon to stay in peace and hope for all humankind.